Alright, once again this is Jeff Scott of Rankin Technical College, and I've been going over for the AWD1100 C-sharp programming class some video presentations from our textbook, Muroc C-sharp 2015. We're in the object-oriented programming section, and I'm in the middle of Chapter 14 on working with inheritance. So I'm going to jump back into the PowerPoints for our book. Again, I will be lecturing on this in class as well, not from the PowerPoints, but I wanted these out there because of what's been going on lately in the world, etc. So you've got yet extra resources that you can go and look at. All right. So we've got the code here for our product list class. Notice product list inherits from the list class of type product. So what are we doing? Modifying the behavior of the add method. All right. So public new void add base insert 0p. So we are changing the natural way that something were to work. In addition, so that's overriding the add method, which normally is just basically it's add followed by something. Here we've got add followed by two parameters. All right. We're also providing two additional methods, one being the fill method, all right, which basically is, as it says, is going in there and it's filling up whatever it is we're working with our list of products, all right, and the other one is for saving. So when we look at the code here, all right, take a look at what's on here, all right. Notice that this is now a more generically written method. In our fill product list box, it's product P in products. Why? All right, because we don't know the product coming in. We don't know if that particular product, we don't know if it is a book or if it's software. We have to be able to handle both of those cases. All right, we've got a delete button and an add button here. Hopefully the stuff that's in there just makes sense as far as what we're doing. All right, we're attempting here to add a new product. Okay, and if everything goes through, meaning all of our checks and everything worked, we want to save it and put it into the list box. Here, this line is saying, did we actually choose a product? If we have not chosen a product to delete, then the selected index will be -1. Remember that the first index number is number 0. All right, so if it's not -1, we just ask, are you sure you want to do this? If they come back with a message box, and if they come back and say, yes, we do, you remove it. You don't say, are you really, really sure? And then we've got our exit method. All right, here's the new product form. So again, notice what we're looking at here. All right. What we can do here is we can end up, we've got our choice here when you look at this. I'm backing up here. Do we want this to be this two different forms, one form for a new book and one form for a new software, or do we want one form? And based on which of these is checked or clicked, checked is really the right term. If that's checked, we want it to be author in this, and if that is checked, we want it to be version in this. All right, and that's kind of what we're looking at in here. So if book is checked, the label is author, and the tag we're using for the text box is author. All right, otherwise we're assuming that it's software, so we're doing the same kind of thing. All right, but you'll notice, all right, we're basically running it the same way. Okay. Our valid is the same as it was previously. So talking next about the type class. All right, I'm around page 466 in the book, And notice what it has here. Properties. All right. These are the properties of the type class. So the name returns a string that contains the name of a type. All right. So what do we have here? Full name is got the fully qualified name. So anything before it. Base type, as it says, returns a type object that represents the class that a type inherits. So basically, it's kind of the parent. Namespace contains the name of the namespace that contains that type. And get type, as mentioned here, returns a type object that represents the type of the object. Every object has a get type method, and again, that get type method returns a type object that corresponds to that object's type. You can use those properties that are shown above to get additional information. Right. And again, I'm not even saying that's the only way of doing this. That is a way, that is a popular way of doing this. So here is an example of how you can get information. So what is this? Book. Where is it from? Here. So in other words, what we're kind of doing here is looking through the object hierarchy to see everything that's here. So its name is book. It's based off of product. Its namespace is product maintenance. And its full name then would be product maintenance.book. All right. As it says here, then you can check. Why would this be important? We could check to see if we needed to, if it was of type book or of type software. Methods that display product information, again. All right. It's going to know based on the parameter that was passed in, and this is something that I didn't really discuss before, but it's a concept that's known as polymorphism, which is one of the hallmarks of object-oriented programming. Poly means many, morphism means forms. So again, it stands for many forms. So the idea is, I told you before, imagine that we had a hierarchy where we had animal at the top, and underneath, and so we have an animal class at the top, and underneath that we've got three classes. This is the same example I gave you before: a dog class, a cat class, and a horse class. And we defined that up in the animal class there's going to be a method called speak, knowing full well we'll have to override that method in each of the classes below these, because a dog speaks, says bark or woof or whatever you want to say, a cat purrs or says meow, and a horse neighs, whinnies, or whatever. All right. But the idea with polymorphism is the right speak method will be called based on the type of object that you are referring to at the time. That's polymorphism. So I can use the same name, for example, speak, for a lot of different types of objects, and the system will know the right speak method to call based on the type of object I'm working with. All right? Okay. Now, casting. Okay, so when you look here, let's see. This says book B, display product B. All right? And what it's saying here is, remember what this is. A book is going to have its product code, its description, and its price will all be handled by the parent, which is product, and the author will be handled internally by the book class itself. All right, and that's not a problem. All right. On the other hand, when we do this, if we say product P, and we do the same kind of thing, again, product code, product description, author name, price. Now, when we call display book, and display book needs a book object, so we have to cast our product as a book object. Otherwise, you're going to get an error, because technically product doesn't know anything about display book. Notice casting exceptions. Yeah, it's possible. Why? Because this is a software object, but we're trying to cast it mistakenly as a book object. All right, so you'd want to do it, if you want to do it like that, and I don't know why you'd want to, but you would say, instead of casting it, you'd say P as software. Now when you do this, for lack of better words, it's going to fail, but it'll pass null because it fails the test, because software is software object, not a book object. All right. Abstract and sealed classes. An abstract class is a class that you design that other classes can inherit from, but the abstract class will never be created directly. It'll never be instantiated itself. Such as, well, let's go with the example I've been talking to you about. You've got an animal class that has 3 different types underneath it: dog, cat, and horse. You're not going to instantiate or create an instance of an animal class. It's too generic in nature. But what you can put into an abstract class are things that any class that inherits from that class would have in common. So for instance, let's say that I was working and I was going to make a class that I called account for a bank. Well, every account has somebody's name associated with it. It's like a first name, last name, address, city, state, zip, etc. So I could put all that stuff into an abstract account class. Then when I create a checking account based off of that account class, or a savings account class based off of that account class, then I could have all that stuff inherited. All right. You'll notice that we also, in an abstract class, we have an abstract method. An abstract method looks a little weird because it has no body. It just has the access modifier, which is public, the word abstract, what it returns, which is string, get display text, which is the name, and string sep, which is the parameter that's passed into it. What this means, though, is that any class that is going to inherit from product must have a get display text method in it, and that must return a string. All right, there's an abstract read-only property. You've seen this kind of thing before, a getter but no setter. Here's a class that inherits from the product class. So again, it must have its own get display text. All right. A sealed class is the equivalent of putting, like what we've done in other, is kind of like putting final in front of it. When a class is sealed, what you're saying is it can't be inherited. If you try to create a sealed class, you must do something like this. All right? Sealing a class is a good and a bad thing. It's a good thing because it can make the class work a little better, but it's a bad thing in that since that class can no longer be inherited, what you're doing is you're making it terminal. In other words, it can't be extended anymore or inherited from anymore. Typically, that's a very pompous way of looking at things, because somebody might want to take your code at a later time and inherit from it or break it down or do whatever. You can only seal a property or method if the property or method overrides a member of the base class. So you can seal classes, properties, and methods. All right? And that pretty much is it for inheritance. Before I come back and talk about working with interfaces and generics, I'm going to take a little break and come back and give you some more examples where we're going to deal a little bit more with inheritance. So I'll be back with that in just a couple of minutes.